Go.
Hello, I'm Sarah Fleck.
And I'm Josh Marble.
We are group number 20, and we study the effects of electrode surface properties on the maximum voltage of aluminum air batteries. So the problem statement, batteries operate and tend to corrode and output less voltage over time as they are used. So the objective for this purpose, for this experiment, is to maximize a output voltage for a one-time use battery, such as the aluminum air battery. We want to alter the forms of the electrodes that we are using and see how that affects the voltage output. And then we want to optimize the battery's output for a single use. So we hope that these three talking points will output the highest voltage for us. We're going to change the surface roughness of the aluminum for the battery. So we're going to scratch it up with some sandpaper. We're also using two different types of aluminum in terms of a flat, smooth surface versus a raised, bumpy surface of aluminum. And then we're also going to play around with the charcoal in terms of the grain. So we're going to crush up some charcoal powder, and then we're going to have some really coarse charcoal. So the materials used for this experiment, we have our two types of aluminum, and then we have standard versions of each of those. We also have activated charcoal pellets, which we used a pestle and mortar to grind up for the finer version. We have 1-ply paper towels. We used a mass scale to have equal amounts of charcoal for each battery. We measured our voltage output with a multimeter, and we also used a salt solution, and we just used regular iodized salt and tap water. So the method, we have fine charcoal versus coarse charcoal. Up here is the coarse, down here you can see the fine version. We also have aluminum variations, as I talked about before, with bumpy surface, a flat surface, and then we have standard versions of each of those, and then you can see the saltwater solution right in that Pyrex glass. So we kept three things constant. We had an 80 grit sandpaper to roughen up the surface of our aluminum. We had a constant saltwater concentration of 15.3 milliliters of water per 1 gram of salt. We kept a constant of 9 grams of charcoal for each battery, and the process. We have two independent variables, one being the charcoal, the other being the aluminum. And then our dependent variable is the maximum output voltage from each of those batteries.
So the goal from the experiment was to just maximize our overall output voltage, and to do that we're obviously altering both of our electrodes respectively. The graph you see here shows the flat variant of our aluminum electrode, and we altered that to have a sanded and a smooth version, and then as well you can see that there are grains and powder respectively for each. So when you look at this graph, you can see a very common trend for this particular electrode variation, where the powdered variant of charcoal electrode showed an overall maximum voltage when compared to its grains, and then the smooth version actually outperformed the sanded version of the flat aluminum electrode. So here we have our maximum voltage outputs for the raised or the bumpy aluminum electrode variant. And this one showed a similar trend for the powder versus the grains when you're looking at the smooth, the unsanded version of our raised aluminum electrode. You can see the powder outperformed only slightly higher than the grains. And then when we took the raised aluminum electrode and sanded it, the grains actually outperformed the powder, but only by a small amount. It could almost be said that they're pretty much negligible, that they're about equal in their maximum voltage. So for the raised variant, we actually observed that the sanded version actually had a higher overall output, and the powder and the grains and powder electrode variants we couldn't really draw too many solid conclusions from that one. So here's all of our tabulated data. You can see here the trends that we saw, that the fine powder charcoal overall for most of our experiments showed a higher maximum output voltage. And when we incorporated sanding using 80 grit sandpaper, when we looked at flat aluminum electrodes, it actually did not improve our overall maximum voltage, but when it incorporated it into our raised variant, it actually showed the exact opposite. So having a little bit more data and doing a little bit further experimenting on this would have been helpful so that we could determine exactly what factors really go into play for the sanded versus the smooth variants. And for our conclusions, we saw that the sanded and bumpy aluminum electrode performed the greatest, and the powder charcoal resulted in a higher overall voltage when compared to grains, regardless of the aluminum electrode, of how the aluminum electrode was altered. And the raised version of the aluminum outperformed the flat version of the electrode. This is most likely because the raised aluminum electrode has a higher surface area associated with that because of the nature of how the aluminum was when we had purchased it. For future recommendations, moving forward with this particular experiment to figure out how these electrodes can further be altered to increase our maximum voltage, we would like to continue to maximize our voltage, and to do that we could obviously look at saltwater concentration. We held most of our constants for that, as well as the amount of charcoal, increasing the variations of how much charcoal is used, grains or powder respectively, as well as the saltwater concentration. The exposed surface area of the aluminum electrode was considered, but it wasn't necessarily measured. We recognize that the raised aluminum has an overall higher surface area than the flat, and that did show us a trend that we believe to be consistent, but that requires a little bit further experimentation. Incorporating a data acquisition system to acquire voltage and current data would also be a helpful step going forward, so that we can actually measure the discharge time for that as well. Obviously, more iterations per variable is going to give us more accurate data and allow us to draw further conclusions for the sanded versus the smooth variants. Also, the water charcoal, stirring it for equal hydration, we observed that the hydration of our grains was a little bit uneven, whereas the powder was easier to keep fully wet. Equal pressure for all the batteries. They were folded over so that they could have a consistent sort of surface contact with the aluminum electrode when we actually had the battery fully built. And equal sanding. It was a little bit difficult to make sure all of our electrodes were sanded. So that's how we would do this moving forward. Thank you.